stream as well. It has started the stream. Okay. Yeah. So again, I'll be getting back to everybody as far as details on the final exam. So I have to kind of reach out to my supervisor. Next Tuesday is our last session. We're just using these last few days to get as much reviewing as possible. I think yesterday we did sections 1-1. Well, we did as much in the first 3 sections as we could. So today I want to just focus on the next set of 3 sessions. Okay. It's weird. Like when I see you guys' name, I have this urge to like read your name out loud, and I don't want to because we're streaming. I think I checked him in already, or he might be from the last class. Okay, that's fine. So I think he is from the last class. Okay, I'm gonna. Okay, let me check the chat. 2, 1, 19. Okay, let's do those since that was requested. 2, 1, number 19, and 2, 2, number 16. Let me see. Okay. Admit. Let's close this out. So there was a request. Let's hop over here. Let me pull that up again. Cannot see it. Minimize this. I just want to show the chat. So let's go to section 2.2. That's going to be 2.1, number 19. So here, let's preview. If you want me to go over yours specifically, you can use the Ask My Instructor. Else, the one I'm going to pull up is going to be the same question, just with just different numbers. Okay, let's go. Okay, let's go like this, and let's make sure we're showing the proper thing. Come on. Go like this. Okay. All right. So there was a request. Heck, I keep forgetting. I am totally like all over the place. Let's go like this. And then just like this. Nope, that's not what it is. Number 19. Okay, let's go to number 19 first. That's the last one here. All right. So it says a baseball is projected upward from ground level with an initial velocity of this, then the height. Initial velocity of this, then its height is a function of time given by this. Let me see. What's the maximum height, right? So this function tells us the height based on time, right? With this given initial velocity. Notice that if we were to graph this like t versus s or x versus y, the highest exponent is 2, which means it's a parabola, right? And the leading coefficient is negative, which means it opens downward. So we have a parabola that opens downward. So then the maximum height is going to occur at the vertex of this guy, right? So we can use the vertex formula to find the maximum height. Okay, let's take some notes and show what we mean by all of this. Let's see, we got it here. Let's go paper. All right, so let's take some notes. This comes from section 2.1, quadratic functions. Quadratic functions. Okay. This is question number 19. Again, it comes from 2.1, question number 59 from the back of that section. So then S is going to be negative 16t squared plus 128t. Right? I want to say maximum. What's the maximum height? H-E-I-G-H-T. Okay. So we're going to show this. Let's hop here. Make sure it's showing. Let's get rid of this. It's in the way. Okay, that looks good. Okay. So what's the maximum height? So again, the highest exponent is 2, which means it's a quadratic. That means that the shape of this graph should be a parabola. The leading coefficient is negative. So that means the parabola opens downward. All right. So if we have a downward facing parabola, the max is going to occur at the vertex. So the vertex formula, which is the x coordinate of the vertex, which is our h, that's going to be negative b over 2a. All right. So in this case, that's going to be negative, our b in this case is 128 over 2 times our a is negative 16. All right. So it's basically 128 divided by 32. Ooh, good job. That sounds really nice. I hope they do that. Hey Siri, what's 128 divided by 32?
128 divided by 32 is 4.
So the maximum height occurs after 4 seconds, or when x is 4, when t is 4. So then we need to find the maximum height by plugging this in. So then s of 4, that's going to be negative 16 times 4 squared plus 128 times 4. Let's see if we can do this. Hey Siri, what's negative 16 times 16 plus 128 times 4?
Negative 16 times 16 plus 128 times 4 is 256.
And the units, probably feet. Okay. All right, so let's hop back over to Pearson. Make sure that's on. Okay. And the units are feet. 256 feet. What is the maximum height? Should be 256. Okay. And then I think there was another request for 2, I think it was number 16. So let's hop over here. Let's open up 2, 2. And I just want to preview, and let's go to question number 16. So this opens. I don't know why it's going slow. Okay, let's hop to question number 16. Let's see something. Maybe if I do. It's already empty. I don't understand what's going so slow. Let me try another thing, something else I can do. I might have too many things open, but it's not. These are all things that I don't know. I might have too much open, but it's not a lot open. It's just the stuff that I'm using right now. I don't want to shut this down, but let me reboot it. Okay, instead of Pearson, like I only use this device for teaching. It might just be old. Pearson. Yeah. Only other thing I could think that would help is if I restart the whole computer, but that's going to eat up all of our time. But I guess the rate at which it's moving now is eating up our time too. If I can't get it to show in the next 10 minutes, we might have to call it a day. Okay. Oof. Okay. Let's do like this, like this. Okay. I think it was two. Two. Let me check the chat again just to make sure. 2 number 16. That's this one. Okay. Okay, this looks good. Let's go like this. Let's see. Okay. Like this. And make sure it's showing. Okay, that looks proper. Let me see if this works. That looks correct. Okay. All right. I think we're back. Okay, use the intermediate value theorem to check whether the polynomial function has a zero. Okay. So all the intermediate value theorem, again, because polynomials are smooth continuous curves, if we want to verify that it has a zero somewhere in between in this interval, all we do is plug in the endpoints and show that there's a sign change. So when we plug in 1 and we plug in 2, as long as there's a sign change, this is a polynomial, then that's what we need. To actually calculate the zero, they really want us to break it up into several intervals and test each interval, test each endpoint. I'm just going to use the calculator. Let me see who's in the waiting room. moving slow today. There we go. Okay. So let me do the following. I think it'll be easiest here. So I'm gonna open up my calculator, which is here. Like this, and then let's hop over here and let's show this for everybody. Okay. Actually need a copy stop. Let me go back over here real quick. So the function, this is comes from two polynomials. This comes from number 16. This comes from 37. We have this p of x equals 2x to the fifth minus x squared minus 15. Okay. And we want to show that it's between 1 and 2. So let me reload and refresh. Two x to the power of 5 minus x squared minus 15. So for instance, if I call in that function, when x is 1, we get this answer. When x is 2, we get this answer, right? So because the sign goes from positive to negative or negative to positive, that means it has to cross the x-axis somewhere between 1 and 2, right? So then, another way, so I'm going to do the table. I'm going to go to table set. I want the table to start at 1, and I want it to change by 0.1. Now when we go to look at the table, it'll start at 1. You see the sign change right there between 1.5 and 1.6, right? We have the sign change between those two. So now I'm going to go back to table set, and I want it to start at 1.5, and I want it to change by 0.01. So now we're getting a more accurate decimal. Now when we go back to the table, this is just one way. There's still another way. We see a sign change here as we go from 1.54 to 1.55. I'm gonna do one more. I'm gonna go back to table set. I wanted to start at 1.54, and this time I wanted to change by 0.001. Whoops. I wanted to go to the table, not graph. Okay, let's go to the table. And then it looks like the sign change, it changes from 1.54 to 1.541, right? So then both of those round to 1.54, right? So this is just one way to do that. I'm gonna hop back over to Pearson and make sure it's displaying properly. Okay. The approximate 2 decimal places, I think we said 1.54. 1.54. Just like that. I hope that answered the question. I know it took a while to get there. Let me check the chat. Okay. So then I'm going to hop back to, I'm just going to go to section 1.5. So if I go like this, so if we go to section 1.5 is here, I want to preview this. Just trying to get through as many questions as we can with whatever time we have. So then, let's do full screen. Maybe it's like this. Let's make sure it's displaying properly. Okay. Describe the transformations, right? So we have our parent function of square root of x. So this one we did a +1 on the outside, so that moves it up by 1 unit, right here. Okay. Oh, for the next one we subtracted 4 on the outside, so that moves it down by 4 units. 4 units down. Okay. Okay, so if this is the base function, if we multiply the outside by a negative, that's going to flip it vertically. So it's going to flip over the x-axis, top to bottom. If we multiply the inside by a negative, that's going to flip it horizontally over the y-axis. Okay, so the base function here is the reciprocal function, which is 1 over x. So we multiplied it by 8. So we start with the graph of 1 over x. We're going to stretch it vertically by multiplying each y value by 8. Okay. Yeah, let's see. Started doing something like this last time too. It just, I don't know. It's technology. Okay. So here we have a parabola. And all we did was move it down by 8. So I'm going to click here. Everything is still moving slow. I don't know. And I think the computer does need to be rebooted. But by the time I reboot it, class is going to be over. I'm gonna give it another 5 minutes. If it doesn't like act right within the next 5 minutes, then I'm gonna call it. Because it shouldn't. Let me see what else I can do. There's not really anything on here. Traction is empty. Might just be because it's Friday. Okay, guys. I think I'm done with this stuff. I'm gonna let you go. And we'll just we'll reconnect back on Monday at our usual meeting time. So I only have 2 sessions left. Hopefully it'll behave better at that time. But it's been moving slow like this whole time. Okay, guys. Enjoy the rest of your day. If you don't have any questions, I'll see you on Monday.